According to the National Electrical Code, it is generally against code to lock a fuse disconnect on with a maintenance lock. National Electrical Code Article 110.25 states that disconnecting means shall not be locked in the on position. National Electrical Code Article 430.102b states that service disconnecting means shall be accessible at all times. Locking a fuse disconnect on with a maintenance lock can create several safety concerns. Firstly, electrical hazards. If there is a problem with the circuit or equipment, it will not be possible to quickly disconnect the power using the fuse disconnect, and this could lead to electrical fires or shocks. Secondly, delay access to disconnect. In an emergency, it may take longer to cut off power to the circuit because the nearest disconnect would be inside the plant, and this delay could increase the risk of injury or damage. While security is a valid concern, there are alternative methods to enhance security without compromising safety. For example, install passive infrared motion sensors or security cameras. These devices can detect movement and trigger alarms if necessary. Another option is to use timers or photocells. These devices can automatically turn on the lights at specific times or when it gets dark. Install additional lighting. This can deter potential intruders by making the area more visible. Based on the National Electrical Code and safety concerns, it is not recommended to lock a fuse disconnect on with a maintenance lock for parking lot lights. Instead, explore alternative security measures that do not compromise safety. The National Electrical Code is a comprehensive set of standards that governs electrical installations in the United States. It's designed to ensure safety and prevent electrical hazards. Fuse disconnects are safety devices that protect electrical circuits from overcurrents. They combine a disconnect switch with fuses. The disconnect switch allows you to manually shut off power to the circuit, while the fuses protect against short circuits and overloads. Locking a fuse disconnect on defeats its safety function. If a fault occurs in the circuit, the fuses will still blow, but the disconnect switch cannot be used to quickly cut off power. This can create a dangerous situation, especially if someone is working on the equipment or if there is a fire. Accessibility is crucial for safety. The National Electrical Code requires that disconnecting means be readily accessible so that in an emergency, power can be quickly shut off to prevent further hazards. Locking the disconnect on violates this requirement as it prevents authorized personnel from immediately de-energizing the circuit. In the case of parking lot lights, a 277-volt feed with 4 1000-watt lamps presents a significant electrical load. A fault in such a circuit could result in a substantial electrical event. The 7 to 10 minute delay to access the nearest disconnect inside the plant is an unacceptable risk, as it could exacerbate the consequences of an electrical incident. Motion sensors offer an effective way to enhance security while conserving energy. They detect movement and activate the lights only when needed, reducing unnecessary illumination and deterring potential intruders. Security cameras provide visual surveillance, allowing for monitoring and recording of activity in the parking lot. This can help to identify and prevent criminal behavior. Timers and photocells automate the lighting schedule, ensuring that the lights are on during the hours of darkness, providing both security and convenience. Additional lighting can improve visibility and deter crime. Strategically placed lights can eliminate dark spots and make the area more secure. When considering security measures, it's important to balance security needs with safety requirements. Locking a fuse disconnect on compromises safety, while alternative measures can achieve the desired security without creating additional risks. Always consult with a qualified electrician to ensure that electrical installations comply with the National Electrical Code and other applicable standards. A professional electrician can assess the specific situation, recommend appropriate safety measures, and ensure that all work is performed in accordance with code requirements. By following these guidelines, you can ensure the safety of your electrical system and protect yourself, your employees, and your property from electrical hazards. Understanding the purpose and function of electrical components is essential for maintaining a safe electrical system. Fuse disconnects are designed to protect against overcurrents and provide a means of safely disconnecting power. Tampering with these devices or bypassing their safety features can have serious consequences. Regular inspections and maintenance are crucial for ensuring the proper functioning of electrical equipment. Fuses should be inspected periodically to ensure that they are in good condition and of the correct rating. Disconnect switches should be tested to verify that they operate smoothly and make good contact. Any damaged or worn component should be replaced promptly. Proper grounding is another essential safety measure. Grounding provides a low-resistance path for fault currents to flow back to the source, tripping the circuit breaker or blowing the fuse and preventing electrical shock hazards. All electrical equipment should be properly grounded in accordance with the National Electrical Code. Electrical safety training is essential for all employees who work with or around electrical equipment. Training should cover topics such as electrical hazards, safe work practices, lockout-tagout procedures, and the proper use of personal protective equipment. By providing adequate training, employers can reduce the risk of electrical accidents and injuries. Lockout-tagout procedures are designed to prevent accidental energization of equipment during maintenance or repair. These procedures require that all sources of energy be disconnected and locked out before work begins. Tags are attached to the lockout devices to warn others not to energize the equipment. Following lockout-tagout procedures can prevent serious injuries or fatalities. Personal protective equipment, or PPE, is essential for protecting workers from electrical hazards. PPE includes items such as rubber gloves, insulated tools, and arc flash suits. The type of PPE required will depend on the specific task and the level of electrical hazard. Using the proper PPE can significantly reduce the risk of electrical shock, burns, and other injuries. Arc flash is a dangerous phenomenon that can occur when electrical equipment is energized. An arc flash is a sudden release of electrical energy that can cause severe burns, blindness, and even death. Arc flash hazards can be reduced by using proper work practices, wearing appropriate PPE, and installing arc flash protection devices. The National Fire Protection Association, or NFPA, is a leading organization that develops and publishes codes and standards related to fire and electrical safety. NFPA 70E is a standard that provides guidance on electrical safety in the workplace. Following NFPA 70E can help employees protect their employees from electrical hazards. Regular safety audits can help to identify and correct potential electrical hazards. Audits should be conducted by qualified personnel who are familiar with the National Electrical Code and other applicable standards. By conducting regular safety audits, employers can ensure that their electrical systems are safe and compliant. A safety management system is a comprehensive approach to managing safety in the workplace. An effective safety management system includes elements such as hazard identification, risk assessment, hazard control, training, and communication. By implementing a safety management system, employers can create a safer work environment and reduce the risk of accidents and injuries. Emergency preparedness is essential for responding to electrical incidents. Employers should have a written emergency plan that outlines the steps to be taken in the event of an electrical fire, shock, or other emergency. The plan should include procedures for contacting emergency services, evacuating the building, and providing first aid. Communication is essential for maintaining a safe work environment. Employees should be encouraged to report any electrical hazards or unsafe conditions to their supervisor. Regular safety meetings can be used to discuss safety issues and reinforce safe work practices. By fostering open communication, employers can create a culture of safety and prevent accidents and injuries. Electrical safety is a shared responsibility. Employers, employees, and contractors all have a role to play in ensuring that electrical systems are safe and that work is performed in a safe manner. By working together, we can create a safer work environment for everyone. Consider hiring a professional security firm to assess the security vulnerabilities of the parking lot and recommend appropriate security measures. A security firm can conduct a thorough assessment of the area, identify potential weaknesses, and develop a comprehensive security plan. Remember that laws can change. It is important to stay up to date on the latest electrical codes and regulations to ensure compliance. Check with your local authorities for the most current information. Document all safety measures taken to protect against electrical hazards. This documentation can be used to demonstrate compliance with safety regulations and to track the effectiveness of safety measures. It's essential to understand the load requirements of the parking lot lights. Full 1000-watt lamps draw a significant amount of current. Ensure that the circuit is properly sized and protected to prevent overloads and potential hazards. The type of disconnect switch is important. A fused disconnect provides both a disconnecting means and overcurrent protection. Ensure that the disconnect switch is properly rated for the circuit and that the fuses are of the correct size and type. The location of the disconnect switch is critical. It should be readily accessible and clearly labeled so that it can be quickly located in an emergency. Ensure that the disconnect switch is not obstructed by any objects or equipment. Consider the environmental conditions in the parking lot. The disconnect switch should be protected from the elements such as rain, snow, and extreme temperatures. Use a weatherproof enclosure to protect the disconnect switch from the environment. Regularly inspect the disconnect switch for any signs of damage or wear. Check for loose connections, cracked insulation, or corrosion. Replace any damaged or worn parts promptly. The National Electrical Code requires that all electrical equipment be properly labeled. Ensure that the disconnect switch is clearly labeled with its voltage, amperage, and other relevant information. Proper labeling can help to prevent confusion and ensure that the equipment is used safely. Proper wiring practices are essential for electrical safety. Ensure that all wiring is done in accordance with the National Electrical Code and other applicable standards. Use the correct wire size, insulation type, and connectors. Avoid splicing wires whenever possible. If splices are necessary, use approved splicing methods. Ground fault circuit interrupters, or GFCIs, are devices that protect against electrical shock. GFCIs detect ground faults and quickly shut off the power to the circuit. Consider installing GFCIs in the parking lot to protect against electrical shock hazards. Surge protection devices, or SPDs, protect against voltage surges. Voltage surges can damage electrical equipment and cause fires. Consider installing SPD in the parking lot to protect against voltage surges. Regular maintenance is essential for ensuring the safe and reliable operation of electrical equipment. Develop a regular maintenance schedule for the parking lot lights and other electrical equipment. The maintenance schedule should include inspections, testing, and cleaning. The National Electrical Code contains specific requirements for the installation and maintenance of electrical equipment in hazardous locations. If the parking lot is located in a hazardous location, such as an area where flammable materials are stored or used, ensure that all electrical equipment complies with the applicable requirements of the National Electrical Code. The Americans with Disabilities Act, or ADA, requires that parking lots be accessible to people with disabilities. Ensure that the parking lot lights do not obstruct access to parking spaces, walkways, or other accessible features. Consider the light levels in the parking lot. The light level should be sufficient to provide adequate visibility for pedestrians and drivers, but not so high as to cause glare or light pollution. Use appropriate light fixtures and adjust the aiming angles to achieve the desired light levels. The National Electrical Code requires that all electrical work be performed by qualified personnel. Ensure that all electrical work in the parking lot is performed by a licensed electrician or other qualified person. Before beginning any electrical work, de-energize the circuit and verify that the power is off. Use a voltage tester to confirm that the circuit is de-energized. Follow lockout-tagout procedures to prevent accidental energization of the circuit. Wear appropriate personal protective equipment, such as rubber gloves and safety glasses. Avoid working in wet or damp conditions. Keep your work area clean and organized. Use the correct tools for the job. Follow all safety procedures and instructions. If you are unsure about anything, ask for help. Report any electrical hazards or unsafe conditions to your supervisor. When working with electricity, it is always better to be safe than sorry. Remember, safety is everyone's responsibility.